So we talked about stacks. We looked at infix to postfix conversion. And we also looked at how to implement a stack using a list. And now it's interesting that we can also do postfix expression evaluation using a stack. Okay. And let's see how we'll do this. So let's say I have this, first let's take this infix expression. And I'm assuming single digit numbers. You can work with higher order digits if you wish. So the result should be 37 minus 4, 30, 34. The answer should be 38. Okay. So let's convert this to postfix first, and let's say this is the expression that we have. I'm just using the algorithm that we already know. Then I see a bracket, 2 slash minus, and then finally the plus. Okay. So this is the expression that I have. So this is our postfix expression. Okay. Now this postfix expression, how do we evaluate? Let's see how we can evaluate this. I start from left. I see operand. Notice that this is going to be slightly different. From in the infix to postfix conversion, what we did was we stacked the operators. Here we're going to stack the operands. So what do we do? As long as I see an operand, I will push it on top of the stack. Then I see an operator in the input. Okay, so all these three elements get stacked. I see an operator. Then what I do is I pop the top two elements from the stack, and the top most element is, because it's left associative, 6 is operand 2 and 5 is operand 1. So I pop it, perform the multiplication. This is 30. I push it back onto the top of the stack. Okay, so star is over, then I have a plus. Okay, so when I see the plus here, what I do? I see 30. I pop both 4 and 30, add and get 34, and I push 34 back on the top of the stack. So where am I now? I have come till this plus over here. So I've come up to this plus over here. Now I have 762. Okay, 762. What will I do? As long as I see an operand, I'm going to push it onto the top of the stack. 34, 7, 6, and 2. Then what do? I see a slash over here. Then I divide 6 by 2. Now I see a slash. I divide 6 by 2, 34, 7, and 3. Now after this, what do I see? I see a minus. Okay. Now, so I pop 3 and 7. I do 7 minus 3 gives me 4. Push it back on the top of the stack. And then finally I see the plus. I pop both the elements, 34 plus 4, equals 38. So what did we do? We had again a stack of operands. And when does this complete? Once the stack is empty, you're done. Okay. And when we see an operator, we pop, because they're all binary operations, top 2 elements from stack, perform the operation, push it back on stack, top of the stack. And we repeat this until stack is empty. Okay, very simple. I want you to think about what you will do for unary minus at the beginning. Think about this. So we have seen stacks as an ADT, and we've seen applications of stacks, infix to postfix, postfix evaluation. Interestingly, even converting a postfix expression to infix will also use a stack. And then you've said balancing of parentheses. Then anything that has a left and a right, and there is some kind of a what you call order in that can be processed using stacks. Then we said recursive function calls. Why recursive function calls? Because the most recent function call has to be evaluated first, as we saw in many recursive functions. So there are many applications of stacks, and it's interesting that we believe that even human behavior is almost like a stack. Stack, and let's see how this happens. You're attending this particular class. In the meanwhile, there is a side chat from your friend. So you put my lecture on top of the stack, then chat with your friend. The chat is over. Then once again, you pop this on the stack, get onto the lecture. You see a friend after a very long time. You'll remember the most recent time when you met him and him or her. And then you can go back and trace back to, finally, this person was my schoolmate or something like that. So stack is a very useful data structure, abstract data type, sorry. We should distinguish abstract data type. So I want you to do a few things, which will give you as part of the lab. Implement stack using linked lists and infix to postfix with priority, plus I also want you to write associativity. Okay. So taking something like some operators are right associative, some are left associative. How will you work with that? Okay. And there are other interesting things. There's one nice problem called the two stacks problem. And the idea is, I was telling you, these things came about when people like me were as young as you, where we had hardly any space. So how do we implement two stacks in a single array? Stacks in a single array. also, and make sure that all the space is used. Okay. And I want you to write whatever programs you write, they should work seamlessly with either linked list or array or using an ADT to implement the stack. The same application must work all of them as long as you've included the .h file. ADT list to implement the stack. The same application must work. Okay, as long as you included the correct files in your .h file, the definition files. So we'll stop here.